All right, today we're going to pull back the curtain on something that runs our connected world, even if we never see it. We're talking about WAN topologies, which is really just a fancy way of saying the blueprints for how massive computer networks are actually designed and built. I mean, just think about it for a second. How does some huge global company with an office in New York, a data center in Frankfurt, and maybe a team out in Singapore, how do they keep everyone connected like they're all in the same building? That's the exact puzzle we're going to solve right now. Well, the answer really begins with something called a wide area network, or WAN for short. And we're not talking about your home Wi-Fi here. This is the big one. This is the network that stretches across cities, countries, or even whole continents to link all of an organization's different locations together. Right, and like any big, complex project, a WAN needs a blueprint. In the world of networking, that blueprint has a special name, a topology. It's really just the map, the layout that shows how every single device is hooked up to every other device. Okay, so let's get into it. To really get the complex stuff, you've got to start simple. So let's kick things off by looking at the most basic ways to connect the dots on our network map. So the simplest, most fundamental connection you can possibly have, that's point to point. Just picture a private, dedicated phone line, a direct hotline that runs from your main office straight to your most important branch office. It's simple, it's direct, and nobody else can use it. But here's the classic trade-off. A point-to-point link is super simple and really secure. That's great. But what happens when you open a third office? Well, you need a whole new line. And a fourth? You need another one. Yeah, you can see the problem, right? It gets crazy expensive and complicated fast. Okay, so another early idea was what's called a bus topology. The best way to think about this is like a single main street. Every office or every house connects directly to this one central road to send and get information. Everybody shares that one single path. And that analogy? It perfectly highlights the huge flaw here. Just like a real street, if too many people try to use it at once, you get a traffic jam, a bottleneck. But what's even worse? If you get a break in that main road, that central cable, the entire network goes down. It's a massive single point of failure. So next up, the ring topology. This was an attempt to build in a little more safety. In this setup, every location is connected in a circle, like a ring. Data just gets passed from one spot to the next around the loop. And here's the clever part. If there's a break somewhere in the ring, the data can often just go the other way around, which keeps the network from completely dying. But you know what? These basic designs, they just don't cut it for big organizations. They don't scale well. So let's look at how things evolved to handle way more complexity by, well, organizing the chaos around one central point. And that brings us to probably one of the most popular designs you'll ever see in the corporate world, the hub and spoke model. The airline hub analogy is absolutely perfect here. You've got your main hub airport, right? And all the other cities are the spokes. So if you want to fly from one spoke city to another, you and your data have to go through that central hub first. Okay, and this is the big trade-off. The design is awesome because it's so easy to manage. All the traffic flows through one central spot that you control. But that strength, it's also its greatest weakness. It's Achilles' heel. If that central hub goes down for any reason, the entire network is grounded. Nothing goes anywhere. Yeah, that single point of failure, that's a risk most businesses just can't take, especially for their critical operations. So the question becomes, how do you build a network that's truly resilient, one that can survive pretty much anything? Well, you build a web. And this is the gold standard for reliability, the full mesh. In this design, every single site has a direct, dedicated link to every other site. It creates this incredible web of connections. If one link fails, no big deal. The data has dozens of other paths it can take instantly. It is, hands down, the most resilient design you can build. But let's be real, a full mesh is also wildly expensive and a nightmare to manage. And that's why, in the real world, you'll usually find a partial mesh. It's a really smart compromise. Your most important sites, like your HQ and your main data centers, they get all the extra redundant links. But the smaller branch offices, maybe they just get a couple. And here we go, the head-to-head showdown. You can see the trade-offs crystal clear. Hub and spoke is simpler and costless, but you're not getting top-tier reliability. Full mesh, on the other hand, gives you maximum reliability, but the cost and complexity go through the roof. This right here, this is the core puzzle that network architects wrestle with every single day. So how do you choose? Well, think of this table as your quick and dirty guide. If your company is really centralized and the main thing your branches need to do is talk to headquarters, hub and spoke is probably fine. If you need to balance that cost and reliability for your most important locations, partial mesh is your best bet. And for organizations where uptime is everything, you go with full mesh if you've got the budget for it. Okay, so up until now, we've been talking about the physical stuff, the wires, the hardware, the blueprints. But the real game changer in modern networking, it's not in the hardware. It's happening a layer above all that, in the software. So let me introduce you to SD-WAN, which stands for Software Defined WAN. Now, this isn't another physical layout. It's a layer of intelligence, an overlay that controls the network. It can use different types of connections at the same time, like a super reliable but expensive private line, and also a cheaper broadband internet connection. And the software is smart enough to dynamically pick the best road for your data at any given moment. This quote just nails it. You see, in the old days, the roads were fixed. Your data had to take one specific path. But with SD-WAN, the network itself becomes smart. It can sense a traffic jam or an outage on one road and instantly, automatically reroute your data down a better one. No human has to do a thing. Okay, so this is super important to get. SD-WAN doesn't just throw out all those physical topologies we just talked about. Nope. It makes them smarter. You could still have a physical hub-and-spoke network, but then use SD-WAN to create a flexible, virtual, full mesh network right on top of it. You basically get the best of both worlds. All right, let's wrap this up with the key things to remember. First off, topologies are the essential blueprints for any big network. Second, it's all about that constant balancing act, right? That trade-off between cost, complexity, and how much you can rely on it. And finally, remember that modern tech like SD-WAN isn't just another physical design. It's a brain, an intelligent layer that makes the whole network faster, smarter, and way more resilient. And that just leaves us with one last big question to chew on. As the intelligence of our networks keeps moving from the physical wires up into the software, how much is that underlying physical map actually going to matter in the future? Hey, thanks for diving into this with me. We'll see you on the next one.